Good morning, students. In our previous video, we discussed about the firing order, and we were discussing the factor number 2, which was engine cooling. How does engine cooling affect the firing order? This was the talk of the issue, talk of the town, we can say. Now we have to know that we had discussed that this region would be overheated if the cylinder 2 fires just after the cylinder number 1 has fired. Now the task of the cooling system will be much more enhanced. It will be difficult. It will become difficult because the cooling system has to take up this overheated load. It has to cool this part more and these parts less. This part and this part. These parts will be cooled lesser, will be cooled up to lesser extent, and this part of the engine which is between the cylinder 1 and 2 will have to be heated up at a higher rate. So this will increase the burden on the cooling system. However, now consider the second situation. After the cylinder 1 has fired up, this region has become heated. Now instead of the cylinder 2, now cylinder 3 has fired. The cylinder 3 has fired. What happens? The region between this cylinder 3 and 4 and between 2 and 3 will be heated up. Now we cannot say that they have become overheated because they are getting heated up for the first time. Now they have become overheated. Now under this condition, the work of the cooling system will be comparatively easier. It has to take up the heat only from these three areas. Now it will take up the heat from the three areas. However, it has to take more or less a uniform heat from these three areas. Now the cooling load will be more or less equally distributed. So what we want to say that instead of we should not fire from the cylinder number 2 immediately after cylinder number 1, from the cooling load, from the engine cooling load considerations also, the firing order must definitely shift from the second cylinder towards the third or fourth cylinder. However, using this analysis, we can also say that there is no compulsorily a need of firing the cylinder number 4 first. We can also fire the cylinder number 3. Means we have both the choices. We can fire cylinder number 3 also or cylinder number 4 also, but not the cylinder number 2. One thing is for sure, we are not going to fire cylinder number 2 immediately after cylinder 1 has fired. Now the third situation which we have to see is the development of the back pressure. We will be discussing in detail what is back pressure and how it can be avoided. That we have to see. Now that back pressure is related to the exhaust. Suppose we are going to explain this scenario also from the same figure. Suppose cylinder 1 is fired and the exhaust gases flow out of the exhaust pipe. I am underlining it. If the next cylinder is the cylinder number 2, we find that the gas is exhausted from cylinder number 1 from the exhaust pipe. The cylinder 2 will overtake them. See what happens. This is the exhaust pipe, or we have to draw one situation like this. This is the intake valve, this is the exhaust valve, and this is the second cylinder. This is the region between the second cylinder and between the first cylinder and the second cylinder. This is the region between the two. This is the region between the cylinder number 1 and the cylinder number 2, and here starts the second cylinder, you can say. Now what we want actually, if cylinder 1 has fired, the exhaust from cylinder number 1, where will it go? The logic says ultimately it will go to the exhaust pipe for getting exhausted. Now it has moved to the exhaust pipe. Now if the cylinder number 2 gets fired, this cylinder 2, it gets fired immediately after cylinder number 1, what happens that the exhaust from this cylinder also, it will go and overtake the exhaust which was already moving out of the exhaust pipe. Now the rate of the cylinder, now it would require exhaust pipe of greater area, greater cross section area, or we can say an exhaust pipe of greater size, so that the exhaust would be exhausted within the given time limits. Otherwise, the exhaust will get collected. Suppose this is the exhaust pipe, and we can say these exhausts are there and they are coming there for the exhaust. Now, up to this point, when the only cylinder 1 has fired, only the exhaust of cylinder 1 was getting exhausted at a particular rate from this exhaust pipe. Now, since the exhaust from the cylinder 2 has also come up very immediately after the exhaust from cylinder 1, so exhaust from cylinder 2 has also joined it. Now, the rate at which the rate of the exhaust should be increased in order that the exhaust products are not accumulated in the exhaust pipe. This is the exhaust pipe I shall write. Means its cross section area must increase. This it means its size should be increased, otherwise it will lead to accumulation. And if the size is not in, now the primary question arises, what happens if we are not going to increase the size of this exhaust pipe? If we are not going to increase the size of this exhaust pipe, the exhaust products from cylinder number 3 and 4 also will keep on accumulating, and it will result in a back pressure. The exhaust, the products of exhaust or the products of combustion which have got no fuel value in them, actually they may have a very little fuel value. The exhaust also has got a very little fuel value because of the unburnt hydrocarbons, and however its exhaust value is very very less. So these exhaust gases will due to back pressure they may try to get enter into the cylinder via the exhaust valve. So this gives rise to a back pressure, and it is a quite serious condition also. So we have to take care of these things also. And now I am sure that this theory, this principle, this factor also leads to the conclusion that instead of the cylinder number 1, instead of the after cylinder 1 has fired, we should not fire the cylinder number 2, but instead we can fire the cylinder number 3 or cylinder number 4. This is the final talk of the town, or final conclusion that we are getting from these three factors. So for the 4 cylinder engines, there are possible firing order 1 4 3 2 or 1 3 4 2. The latter is in common use, so we can say it is always better to use 1 3 4 2 instead of 1 2 4 3. For a 6 cylinder engine, however, the following could be used, and the first one, actually this one, is in common use. So 1 3 4 2 we generally use it, and I hope these factors and these theories are clear to you. We will discuss the next things in the next videos. Thank you.